All right, so we're just going to jump right into it. We're going to be installing Ollama on the BC250, and then we're going to try to pull Gemma 4. I think I'm going to go with the 12B. It should be kind of tight because I have it set up for 8 gigs of VRAM. So it's split right now. What I'm going to be doing is I'm going to SSH into the BC250, which I've already done because I was having some issues. My firewall was blocking it. So we got that going. The first thing we're going to do is we are going to install Ollama, and I have not done this yet, so we're kind of just, we're learning as we go. I have the commands. See, I already had the OpenClaw in there. I got it. Okay, we'll wait for that to install. By the power of editing, it's already done. We are going to start it. Okay, should be going. Now we're going to pull Gemma 4. Error, pull model manifest file does not exist. I've actually got a change of plans anyways. We are going to pull Gemma 4 E4B. This is a, it's going to be a more capable, it's a mixture of expert model. It's kind of a denser model, so it should work better with less VRAM. And this is going to take a minute because it's 9.6 gigabytes, but it is downloading 117, 118 megabytes per second. So that's pretty good. That's done downloading. So we're going to first type in the correct window. Gemma 4B, what are you and what can you do? First one's probably going to be a bit slow because it's got to load the model in there. So we'll get some actual test error. All right, let's check the status. Experimental Vulkan is disabled. So Ollama isn't using the iGPU. It fell back to CPU only. VRAM is 0. Try stop Ollama. We're gonna enable Vulkan on it. I see an issue already that I didn't notice. So it's showing memory 7.48 gigabytes. E4B is 9.6 gigabytes. It's not going to work. We are going to pull the 4B model here, and we're going to Llama pull Gemma 4B. All right. File does not exist. I'm all over the place. I told you I don't know what I'm doing. I'm learning as I go. This should be 7.2 gigabytes. It's also a MOE architecture. Should be a solid model. All right. I didn't enable sleep on the BC250, and it doesn't like to wake back up. So I lost my SSH session because it went to sleep and I didn't catch it in time. And it won't wake back up. So I'm going to have to restart and re-SSH back into it. We're back where we were. I got E2B installed. I'll put up the specs for E2B. I don't have them all memorized. I told you I'm learning as we go. This is a project, not a how-to. All right, let's go ahead and try that. Let's try to run it, see what happens. All right, first time is a little bit slow because it has to load the model, but everything's going now. Sounds like the fan just... Yeah, the fan definitely just ramped up on the BC250. All right, there we go. And of course, you can use the GUI. Like I said, I'm just SSH'd in right now because I can use OBS, my webcam, my mic, all that stuff, and it makes it a lot easier, and I'm not putting an extra load on there. So you don't have to do everything from the command prompt. And then also everything from that I'm using, if you want to do the command prompt and kind of use this as an example, a lot of it what not to do, I'll have the commands and everything up on my website. I'll put the link in the description, but it's just www.tiredadtech.com. So the next thing I want to do is I want to install Llama-benchy, which is going to help me benchmark how fast it's actually going. So we're going to go sudo pacman. I'm on CachyOS, remember, so confirm. All right, and then we need to install UV system package. Let's try this instead. There we go. package mirrors are out of sync, so we're gonna update it first. And then we're gonna try UV again. That seems to be working better. Clone, get clone, HTTP get. Change directories to Llama-benchy. Okay, then we're gonna UV sync. And what we're gonna do is we're gonna run it. So what it's gonna do is it's gonna run the Llama-benchy benchmark tool against my Ollama instance. So the UV run Llama-benchy executes the benchy script using UV's environment. The base URL points it at Llama's OpenAI compatible API running locally. And then, of course, the model I'm running, it will send a series of prompts to the model and measure two things. It's going to measure the prompt processing speed and the token generation speed. So the prompt processing speed is going to be how fast it reads, processes the input. And then token generation speed is going to be how fast it generates the response. So these are what you guys want to see. It's a lot of numbers and it's a lot of other things. So I think what I'm going to do afterwards is just give it a kind of generic prompt. I'll just kind of time it. PP2048 is prompt processing, 2048 tokens. It did 49.08 tokens per second, which means it's processing about 49 tokens a second. TG32, that's token generation, how fast it writes a 32 token response, and it got 17.07 tokens per second. Best burst speed was 17.67, but we're averaging, we'll say 17 tokens a second. TTFR, that's time to response, how long before it starts replying. So about 38 seconds. That's the cold load time. So like I said, it has to get it in the VRAM and everything first. EST PPT, that's the estimated prompt processing time. Kind of similar to the TTFR, confirms the 38-second load. E2E TTFT, that is end-to-end time for first token. So that's the total wall clock time from request to first word appearing. Our big takeaways, it's 17 tokens a second generation. That's actually pretty decent for an integrated GPU with shared memory on a little budget deal here. After the model warms up, we're getting 17 tokens per second. So what I would like to do now is I just kind of want to get a real feel. So we're going to go Llama run Gemma for E2B. Let's see, explain how a CPU and GPU work together when running in a AI model. Keep it concise. Oh my goodness, I can't type. And then we'll keep it concise. It's thinking. So it breaks down what we got here, the thinking. Identify the AI workflow, determine the integration. That actually wasn't too bad. This is a little bit smaller model. So Gemma 4 is actually pretty good. This is Google's DeepMind's Gemma 4. The E2B is a mixture of experts model. It's 5.12 billion total parameters. It only activates a fraction of them per token. Makes it actually work a lot better than what the size really is. It's running 7.2 gigabytes quantized. So it's a Q4 KM. And it supports a 128,000 context window. It'll handle both text and images. Obviously, I'm in the command prompt. If I was actually doing it, I'm running headless right now. But if I was actually using the GUI from CachyOS, then I could do images and stuff. It's actually really good. I was actually kind of impressed with how fast it spit that back out on me. But I would like to run some larger models. Don't think it's gonna work, but I would like to test it. I have another BC250. So this is my third one. So I have two of them, and what I'm gonna do eventually is I'm gonna connect two BC250s together, and then that will give me 16 gigabytes of, theoretically, 16 gigabytes to work with. The way it's gonna operate is, if it'll work, I think it's gonna be too slow because I have to connect through the network instead, but it's not gonna be 16 gigabytes. I mean, it is, but it isn't. It's going to split the model, so half runs on one, half runs on the other. But we'll try it out. We'll see what we can do. I'm gonna have to do some more research, but it is an idea that I went ahead and pulled the trigger on. So make sure you like and subscribe and check back for that video.